Okay, perfect. Why don't we start? So one more time. Good morning, good afternoon, or good evening, depending on the time zone where you are. We are so happy to see so many friends in the list of attendees and so many past clients of our training courses, our large assembly services. Feel free to reach out to us after this and let us know if you have other questions. And let's start. This is all about hardware this time. And you guys know me, I'm a large assembly guy, so hardware is a cheap way to increase productivity. A couple of things that, just one slide about TriMech, and I just want to give you the good news in case you haven't heard. We joined forces with Solid Solutions from UK, and as you can see, the area of coverage for our clients has expanded significantly. Lots of advantages for you. Very soon, we will be able to offer extended hours of technical support. That's going to be crazy. Can you imagine how many time zones we can cover? I mean, you can wait if you are somewhere in the middle of this map and you wake up super early in the morning, that's going to be somebody qualified to answer the phone. Same thing if you work very, very late at night, plus a lot of other advantages that you might hear from us in the next few webinars. So the agenda has lots of items on there, but it's going to be actually quite light. I'm going to just mention the 3 factors that are impacting productivity, things that you should keep in mind when upgrading. Just also an example on how hardware can impact SolidWorks performance. There are lots of myths out there about what's more important. Is the CPU speed, is the video card, is the memory. And then I'm going to share the result of a real-life test of opening and updating a large assembly. This is something that we do every time we get new laptops here at TriMech. And usually I see an improvement of about 5% in performance from purely upgrading the hardware on the same software and the same type of user. But this year, the results blew my mind, like crazy increases in speed. And I couldn't figure out why they are so much faster. So I invited 2 hardware experts, like you probably know these guys. They are the industry's guru from DELL and NVIDIA, to tell us what they did, what type of magic, what type of trickery they did on the new hardware that they have made available to us to see these huge improvements in speed in a traditional way of using SolidWorks. And that's what we're going to dedicate the most of the time today. And if you stay until the end of the webinar, we're going to share with you a super exciting offer from DELL for our clients. Like, I think I'm going to buy a couple of these systems for myself because the prices are amazing. So let's start. Now, what do you need when you to improve the productivity? Well, first of all, you need to have a computer that is capable of running, let's say SolidWorks in this case, if you guys are using SolidWorks, to support your current use case. And this is what this webinar is all about. What else? Obviously, having the right software. Some of you are probably already testing right now SolidWorks 2023. It's in beta version. Feel free to go and test it. You don't even need to install it on your computer. You can run it in the cloud. So give it a try. I cannot really disclose the huge improvements in performance that I saw in large assemblies because all of us are under NDA until September. So we're gonna leave this for a future webinar. And obviously, if you have a good machine and you have the right software, the most important factor is making sure that the user is, let's say, upgraded. So it's professionally trained, and depending on your use case, is fully capable of taking advantage of this amazing hardware, amazing software. And again, we'll talk about key things to consider in a future webinar. But today it's all about hardware. And as I mentioned, these are the low-hanging fruits, right? everybody would be super happy if you are an engineering manager, if you are an owner of a company. The most expensive part of your business is most likely the human factor. Engineers are expensive. Hardware, not so much. So if I can get even a 5% improvement in performance, I'm going to say those are money well spent. What about more than 5%? So let's take a look. For those of you who do not know me, you might wonder what qualifies me to present this webinar. And I'm going to focus only on one aspect, large assembly and drawing performance. So I have been studying this topic for a long time. I'm working with my clients. Actually, I work with many of you, have been working with many of you. And every day we discover something new. Usually in our large assembly training courses, we focus a lot on software and on techniques, right? Workflows, best practices. We mention hardware, but we take the hardware as a given. You should have a good hardware setup. Well, this webinar is the missing piece from our training courses. Like what's happening today in the hardware world. Okay, so let's take a look at the how SolidWorks is using hardware. And in the past, we focused a lot on simulation and visualize areas where we know multi-cores are important, having a really high-end video card is important. But what about the daily use, things that you use a lot? All of us are opening assemblies, for example, right? Or we are building parts. And what you see on the screen is the chart showing the workflow for opening an assembly, or if we cut step number 1, the workflow for rebuilding an assembly. So what we notice here, first of all, there are 3 phases where SolidWorks is single-threaded. And if you heard the myth that SolidWorks takes advantage of only one core, it doesn't really do multi-core processing, as you can see in this chart, that's true 3 out of 5, at least for opening assemblies. And here you might think, okay, maybe if I have the biggest frequency of my CPU, that's what I need, right? And probably enough RAM, and that's it. I don't really need a computer with lots of cores. And video cards, well, historically, as long as they were certified for SolidWorks, that was good enough, which was true up to SolidWorks 2019. Is it worth getting a higher end video card? Well, as you can see nowadays in SolidWorks 2022, there are certain steps that are multi-threaded, and also certain steps that are taking huge advantage of the video card. As you probably heard in SolidWorks, starting with SolidWorks 2019, the video card is used more and more and more with the new graphic pipeline for parts and assemblies. And starting with SolidWorks 2021, that is true also for drawings. Okay, with that being said, as I mentioned, a TriMech, a large assembly consultant, gets a new laptop every 2 years. Okay, so that's me. So this, until recently, I was using an excellent DELL Precision 5540. You can see here the specs. And this year I got 5560. It's not the latest generation. Since then, a brand new generation was released, 5570. But anyway, it's just 2 generations newer than 5540. If you're looking at the specs over here, there is nothing much to be able to tell the difference. Actually, I made a mistake here. This one has 8 physical cores. This one has 6 physical cores. I'm going to update this slide when after this webinar. So I wasn't expecting huge improvements in performance. Every time I get a new laptop, I do a test, and the test focuses on this cab. So this one doesn't have a lot of parts, but I know exactly what is going to tax in SolidWorks. It's taxing CPU heavily, and it's taxing the video card also heavily. Lots of bodies, lots of appearances attached to bodies. It's pretty crazy. So this is the DELL Precision 5540. It took 8 minutes and 31 seconds to open the assembly fully. And then when I got the new one, I was expecting maybe a 5% improvement in performance. I made sure that I had exactly the same software, the same settings. I was running Windows 10. As much as possible, I did my due diligence to make sure that I have exactly the same settings. So also I opened this like 3 times followed by rebooting the computer, just to try to make sure they are as close as possible setting wise. And the numbers here were 6 minutes and 31 seconds. So if you're looking just on the opening time, there is an increase in performance of 23.5%, which is, I have never seen that when I got a new machine. As I mentioned, usually between 5 to 7%. So this is crazy. I talked to my colleagues, I talked to the guys from SolidWorks. I said, what did you do in the software that would take more advantage of the newer hardware? And I didn't get any answer, any good answer. And then I was testing also the video card. So this is the amount of time that it takes for a 5540 to update the graphics. Now, the thing about graphic generation time, this happens very frequently after the assembly is loaded. You do a change to SolidWorks, you have to wait. You do something, you move from a window to another, you have to wait. So every fraction of a second can impact your mindset, really. Instead of focusing on design, you're just waiting. So the new one is 2.4 seconds, 22% improve in performance. And we saw that consistently with other assemblies that I cannot share with you. So that was pretty crazy. Now, the question remains, what's such a big improvement this year, right? Similar specs, faster performance. So what has changed internally? And I'm talking about the laptop just because I'm running a Dell laptop, and actually my guest is a Dell expert. Same question from the GPU perspective. I have an NVIDIA video card. Both of them are entry level for the professional type of video cards, but I saw a huge improvement in performance. So without further ado, I'm gonna ask Mr. Scott Hamilton from Dell. You probably know him. He's always at SolidWorks World or 3D Experience World, always presenting. And I'm pretty sure we're gonna hear what happened under the hood, what has changed under the hood. And let me give him the control over the keyboard and the mouse. And Scott, if you don't mind maybe unmuting yourself, let us know more about what happens with Dell.
Hey guys, I'm hoping everybody can hear me. Welcome aboard, and thank you, Elaine, for the great introduction. All right, let's dig into the question. What have we done to help improve the performance? So I'm going to start out and talking about, the workloads that Elaine referenced. What we call single or multi-threaded or interactive or computational work. And this is really important to understand because the software that you're using and what you're doing in the software at that particular instance does determine how the system reacts and how it performs. So let's talk about the differences here. First of all, you have what we would call interactive work. And this is typically when you're doing design work, or another good example is when you're doing VR or something. And this is usually when you have a situation where the system is waiting for your input, right? You're thinking, you're making a change, and then the system reacts. So that's what we call interactive. And interactive workflows are actually usually most bound by the CPU clock speed, because you're waiting for that system to respond, and the faster the clock speed you have on your CPU, the quicker it'll respond. And also feed the GPU and various other things. And then you have another type of work that we call computational work, which is where you're typically asking the system to do lots of processing, and some good examples of this are, visualization, rendering if you're using SolidWorks Visualize, or you're using, the SolidWorks simulation modules. And that typically will use a lot of cores, whether that might be CPU or GPU cores. That type of work is typically bound by the number of cores. And you can see here in these graphs, and I apologize, they're a little bit out of alignment there, but you can see the difference between an interactive workload and a computational workload, how it utilizes the system. Okay, so for example, CPU turbo frequency here that you see, the green spike, is something that's very important for interactive workloads. But if we look at CPU or GPU performance, we see a lot of those spiking on the computational workload. So again, when we're looking at optimizing our workstations for maximum performance, we take all of these things in consideration in the design of the workstation so that we can maximize the performance according to how you guys are using the software. So to kind of, tangent off of what Aline already talked about on benchmarking results with the large assemblies, we just recently ran a few tests here on SolidWorks, and here are some of the results we're seeing. And this is comparing a precision 7770 to a 7760. So these are what we would call a generational compare. So we're comparing the previous generation to the current generation with SolidWorks, and you can see down in the birdseed here in the lower left, here's all the details on the configurations of the systems. And, then here's the Spec APC results. Spec APC is a standard benchmarking tool that's open to, in the public domain that you guys can test your system. And here are some of the results that we saw in the benchmarks. And the way this is referenced is anything that's above 0 is an improvement of the 7770 over the 7760 system. And you can see pretty consistently we're seeing, in between, 10 and 25% improvement for most features. And then there's one that's really outstanding there, that's that CPU ray trace, which is, 75% or almost 80% improvement. So that's pretty significant, right? And we'll again get into some details on why that's happening in a moment. But I wanted to share one other result with you. This is a little bit different comparison. Now this one is a generation compare, but over 2 generations. And I like to share these kind of longer period of duration comparisons because, when we talk to users, most customers tell us that their average refresh cycle is 3 years. Some are more, some are less, but so this is more realistic. We could have gone even 3 generations compare, which would probably be most practical, but I didn't have that data readily available. But now here we're testing a 3660 versus a 3640. So that's 2 generations of systems, and you can see that the differences are really significant here. We're seeing averages of like 50% or better, and in some cases, 100 and what is that? Almost 140% improvement in some of these areas. So this just goes to show you that upgrading your hardware can have a tremendous benefit in performance gains. And as Aline mentioned, performance equals productivity. So, if you as an engineer can get your work done faster, that brings a lot of benefits to, your workflow. You can complete your projects faster, you can deliver products to market, you can maybe be better designs, you can save your company money, all kinds of good stuff. And, it's really can be quite considerable because the cost of an engineer to a company is usually, many times the cost of, the hardware upgrade. So it's really important to consider that. So, let's dig into some of the reasons why we're seeing this and talk about how you guys can actually see those differences yourself. So, many years ago, Dell launched this tool called, it used to be called the Dell Precision Optimizer, but it's now been renamed the Dell Optimizer. And this is a tool that allows you to analyze the performance of your system yourself. It does actually a couple of things. Analyzing the performance is one thing. It also allows you to do build profiles based on your real world use cases and enable those profiles so the system automatically, every time you start SOLIDWORKS, it will enable that profile, which optimizes the machine to give you maximum performance. That's what this application section is about. And then there's some other features to help you with upgrades and just managing your audio and power. For example, in the power section, you can set how it uses the battery, when it recharges, or, you can maximize your battery life, et cetera, et cetera. So it has some really nice features. So what I want to share with you here is a really interesting analysis of what happens when you load a model in SOLIDWORKS. And interestingly enough, this analysis that I did was directly based off of that work that Aline was doing. I first met Aline at one of the SOLIDWORKS VAR conferences, and I was giving a presentation on this DELL optimizer tool, and he showed me his work he was doing on the large assembly stuff. And I said, hey, could I get that model and I'll load it and run it in SOLIDWORKS and I'll analyze it and see what happens. And that's exactly what we did. So that's what this shows. So hopefully this will give you a little bit of insights. So one of the first things that you have happen is you have to load the model, right? And so we're going to look at various parts of this. So when you load and rebuild a model in SOLIDWORKS, this is what you see happening. And for a lot of the process that you're in this kind of what I call single-threaded area, and you'll see that the red area, the CPU, the average utilization is about 20, maybe a little bit more than 20%. And the reason for that is because this system was using one CPU out of the 4 available. So it was about 20-25% utilization. But you can also see that in certain periods, when it's doing the tessellation of the models to get it ready to load into the graphics card, or also when it's doing like rebuilding the model tree and things like that, reevaluating the scene dependency graph, then that part is multi-threaded. You can see right in this section where we saw a bump up in CPU utilization because now it's using all the cores. And again, if we look at, here's when it's actually loading the model. So what we saw here is obviously the read utilization on the storage device dramatically increased, and then the rest of the time, it was basically unused because until you go and save or load some new model, that's going to be what it is expected. Now, I will talk a little bit about storage devices while we're here. So as you guys know, SOLIDWORKS highly recommends that you use SSDs, and that's part of the reason we're seeing some performance gains in Aline's benchmarks, is that SSDs are getting better and better in performance, and we've seen some technology advances in that respect, going from hard drives to SATA-based SSD drives to then PCIe-based SSD drives, and then recently that's not even in the data yet, but we'll probably see another little bump in performance going from Gen 3 PCIe to Gen 4, and then also Gen 5. So we're going to be expecting to see some more performance bumps in that area in the future as well, as new systems take advantage of that technology. And then, this is where we've loaded all the data in there. It's been tessellated and it's loaded in the graphics card. And now we really see where the GPU utilization goes up dramatically because we're starting to do our modeling operations. We're spinning the model around, looking at it in different views, maybe changing the view states to see it, transparent or different, hidden lines removed, whatever it might be, right? Fully shaded wireframe. And here you can see there's a bump in the GPU utilization. And there's a lot of reasons why we see, GPU performance gains, and Dawn from NVIDIA is going to really cover a lot of those. So I'm not going to spend a lot of time talking about that here, other than the fact that, every generation of system, we, take the latest and greatest NVIDIA graphics, and those provide some really great performance benefits that you'll see, and Dawn will talk about some more. And then finally, the other section is when we're loading the model into memory, we see this, bump in, the memory utilization and the pages per second, which is basically, we're reading the model off of the disk and loading into the memory. So you can see what's happening here. So the great thing about this tool is it allows you to analyze all these different components of the system and see what's happening as you're doing your work. And then, you can look at these graphs and determine, hey, do I have a bottleneck somewhere? Like, for example, if you saw that your memory utilization, which is this dark blue line, it's up at about 40%, which is very acceptable. But if you saw this up above 80% consistently, then you would want to consider maybe increasing the amount of memory in your system, because now you're getting in the area where the system is going to probably regularly, it's going to swap a lot, and you would see a lot of these pages per second. You would see a lot of spikes in here. And basically what's happening is your system doesn't have enough memory, so the system has to start swapping and putting some things on the swap device, your storage device, which is an SSD, which is fast, but it's nowhere near as fast as memory. So that will cause actually some performance bottlenecks and actually limit your CPU and your graphics performance, because essentially the system is starved for data. It can't get all the data in it needs. And that can cause pretty dramatic performance degradation when that happens. So just another way you can analyze what's happening on your system. And then here you can see, this is everything kind of piled on top of each other. So you can see what's happening in the whole process of loading that model, spinning it, and manipulating the data. And you can see that, that just gives you an overall picture. So I encourage you to use this tool if you think you're seeing some, performance issues. Use the analytics option on DELL Optimizer. And then, of course, you can always use the application profiles at any time when I would encourage you to just turn on DELL Optimizer, run the profile generator, and you just do your work for a couple hours, and DELL Optimizer will analyze your system and what you're doing, and then it'll build a profile for you that will memorize what you've done, and then it'll optimize the system automatically every time you start SolidWorks. So that's a great tool to use. So now we saw some of the things that are happening on the system, and let's talk about what DELL does overall to help design workstations for really what I would call engineering use cases. So first of all, we work really closely with SolidWorks, and we're always certifying our workstations on the SolidWorks products and many other ones as well. So when you buy a DELL Precision workstation, you're going to get something that's been tested and validated by SolidWorks to work as you expect. Of course, I talked about the optimizer. We offer a lot of customizability, configurability, expandability on our systems that allow you to pick the right system for what you're doing. Because if you're using SolidWorks just for design work, or maybe you're using some simulation, maybe you're using Visualize, the demands on the system are very different, and therefore the configuration you buy should be very different to meet your needs, right? Also, we offer ECC memory and DELL reliable memory technology. This helps prevent memory errors and blue screens on the system. We offer a premier color display, so especially if you're doing anything that's color critical, like the more industrial design work or visualization where color matters, and that's really important. So one of the things that we always talk about with precision workstations is it's kind of like the old adage in real estate, what's the most important things in real estate? And everybody will tell you location, 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 right? Well, for performance on workstations, it's a performance, 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 right? Because we know that engineers are pushing the systems to the limits. When do you ever get simpler models? Things always get more complicated. You're always being asked to do more and do it faster. So performance is the most important thing, and that's what we're always stressing in our design to maximize the performance. So we work with partners like NVIDIA and Intel and many others to always get the latest and greatest technology, but also we have to put it in a design and a package that meets the end user needs. And that's, all of those things together are really enable us to give you, better performance every generation of hardware release. So for example, we're optimizing the performance of the system by providing the best in class cooling and thermal solutions in our workstations to help maximize the performance. One great example of that is, DELL consistently can overclock the memory speed in our mobile systems because we've proven to Intel that we can keep the system cool in situations that they normally would start downclocking the memory to provide thermal overloads. And now we're able to overclock the memory in certain situations to give you better performance. And there's all kinds of other benefits, things like, the clock speed and because of our cooling solutions, we're able to keep the system turbo up higher than many of our competitor systems because of our excellent cooling and design. And I'll just take a little bit of a tangent on that. We talked about single-threaded performance, how important that is for users using SolidWorks. And if you guys go back and look on the SolidWorks website, you'll see that they recommend a system with at least 3 gigahertz on the clock speed, right? And you'll notice that, and we'll see this in some of the recommendations, but even on the specs that the Aline mentioned in the systems he tested, you'll notice the clock speeds were like 2.4 gigahertz, right? But remember, there's 2 types of clock speeds here. There's the base clock speed, which is kind of like the minimum clock speed the system's going to run at, and then there's the turbo clock speed. And this is a feature that's inherent in Intel processors that allows the system to increase the clock speed based on the number of cores that are being used. And usually the lesser cores that are being used at the time, usually you can increase the clock speed even higher. So some of our new systems actually go up even as high as 5.2 gigahertz. So don't just, if you just look at the specs, make sure you consider, both the base and the turbo. And most of our systems will run pretty consistently if you're using a few cores up towards the limit of the max turbo. So that's always good to know, right? So some of the other things that I'll talk about too is some new enhancements as well that are coming in that came in the latest architecture, and that I'll talk about that in a minute after I introduced our product line. So this is our current product line, and we really break it down into kind of 3 different series of products: 3000, 5000, and 7000, and then we have mobile tower and rack workstations. So, we have a lot of different solutions for you based on your needs. Obviously, mobile devices are all, for, people that need that mobility. They, work in the office, they have to take their system home, or they need to travel, which is, of course, extremely popular these days with, all the ramifications of COVID and everything. Our tower workstations are, built for maximum performance and expandability, all the way up to systems up in this range, where you can have 56 physical CPU cores, turn on hyper-threading, and that gives you, 112 physical cores and multiple NVIDIA GPUs for, to boost your SOLIDWORKS visualized rendering. And then we also have rack workstations that allow you to, actually, they're very similar to the towers, but now they're in a rack form factor, so you can mount them in a server rack and put them in a data center and then access them remotely, which allows you to take the space, the heat, and the noise out of the working environment. So that's kind of a nice feature. Now, one of the things that we, launched in our all of our mobile systems on our entry tower workstations was the new Intel Alder Lake technology, which has this hybrid core technology. So there's two types of cores. There's what they call performance cores, and there's efficiency cores. And so if you look at the specs of a CPU, an Alder Lake CPU or 12th gen, then you'll see there's typically more cores on the system. And there's a balance between performance and efficiency cores. And then you'll also notice that, I think some people, might at first be a little bit concerned about is, again, comparing the base clock speeds, you'll see that they went down. When I first saw that, I'm like, oh, wait a minute, that's very concerning, because a lot of things in SOLIDWORKS are single threaded, and we're really trying to maximize that clock speed. Well, it turns out that, again, that turbo mode that allows us to increase the clock speed is working in our favor. And also, Intel has done some optimizations on the actual compilers to give more efficient use of the cores, and actually it will run at a faster, overall performance, even with a lower clock speed. But now, because the turbo speed's even been further enhanced, we're kind of getting a double bump in that ability. So again, I just want to remind you, when you see that base clock speed of 2 point whatever gigahertz, don't be concerned, because your system's going to run well above that. Again, probably closer to the, in the high 4s or low 5s gigahertz clock speed when you're in single threaded operations. So something really important to be aware of. Okay, and I have in here, and again, I'm not going to spend a lot of time going through the details of all of these items on the recommendations, but I do have a number of recommendations in here. We'll make sure you guys get a copy of this presentation so you can see these, but we've provided some really good recommendations for the current generation of hardware in different use cases. So this is for, design and analysis. We recommend like a 5770, an A2000 level graphics with a 14 core system. And again, remember, that 14 cores is pretty high. And you can see the 2.3 and the 4.7. So that 4.7 is the turbo speed. That's the one we want to look at when we're, looking for that single threaded performance. So that's the number you want to be concerned with. The only time the system is going to run at 2.3 gigahertz is if you're using all 14 cores at the same time. And that might happen if you're running something like SOLIDWORKS simulation. But that's okay, because now you're utilizing all of those cores, and that's going to in itself increase the performance. So we've got some recommendations here for design and analysis. We have some recommendations for trying to get the slide to advance, visualization, and we have some recommendations there's some for visualize in there as well. So I'll just touch really quickly. Here's some great accessories just to consider when you're buying your workstations: the 3D connection, space navigator. You know, we have the advanced keyboards. I talked about those monitors. You know, we also offer the HTC Vive Business Edition if you're doing some VR work as well. So I'll just point you to this stuff really quickly. Again, you guys will get a copy of this so you can reference all this stuff. Here's a bunch of links that give you recommendations. There's information about the optimizer, hardware certifications, our TriMech DELL expert network, which Aline will talk a little bit towards the end of the webinar. So anyways, I hope that you guys found that useful, and I want to hand it over to Dawn from NVIDIA to talk about all the great things that the graphics system will help you guys out with on SolidWorks.
Thank you very much, Scott. One thing that you remind me is the analyzer capabilities of the DELL Precision Optimizer. I have to run it again because that was really cool. And then I'm gonna give you control over the mouse and keyboard right now. And for those of you who haven't seen Dawn before, I think there is pretty much nobody who hasn't had a chance to attend one of his presentations. One thing that I know is that he has been with NVIDIA pretty much for the duration of the time that SolidWorks has been focusing on improving performance, which started officially about 4 years ago, like with SolidWorks 2019, yep, where they started rewriting the graphic pipeline. So in a way, Don has been working with SolidWorks for even more than that. And that being said, Don, allow me just move my mouse to mute myself, and then it's all yours.
Sure, sounds good. Thank you, Alan, and thank you, Scott, for going over that stuff. You guys can see who I am. I've been in NVIDIA for, I don't know, 5 or 6 years now. Let's see, can I advance the slide yet? There we go. So I am a Senior Alliance Manager at NVIDIA, as Alan said. My name's Don Breda, and I manage NVIDIA's basically our strategic partnership with SolidWorks, along with some other software vendors in the manufacturing and architecture industries. So what I want to get into, and what I don't want to waste a lot of time, so we're just going to dive into it. So why are NVIDIA GPUs so much better for your SolidWorks workflows? So the NVIDIA RTX platform is really the most advanced visual computing platform available for professional customers. And over the past couple of years, NVIDIA has expanded the availability of that RTX technology for professional customers, from desktops to laptops to the data center and the cloud, public and private clouds, and embedded devices. And what the platform does is it really enables customers to take advantage of cutting-edge technologies such as GPU-accelerated rendering, simulation, data science, and compute. And the RTX platform supports virtualization of powerful virtual workstations, along with the ability to provide compelling extended reality experiences through VR and AR as well. So the GPUs become an essential engine for everything that drives all these workflows. Each new architecture of our GPUs improved on performance, efficiency, and capabilities to drive more advanced workflows and to raise the bar for graphics and computing. Some of you might be familiar with the Turing architecture that we released several years ago. This was a huge leap forward for computer graphics. Turing introduced NVIDIA RTX technology for the first time, bringing real-time ray tracing powered by the NVIDIA RT cores, and I'll talk more about those later, and AI acceleration powered by the Tensor cores to professionals, opening really a new world of photoreal graphics and AI-enhanced productivity. Most recently, with the launch of the NVIDIA Ampere architecture, we made yet another leap. Really, we took the advancements that we made with Turing and we doubled the throughput of our RTX technology. And as a result, performance has been amplified to a new level, producing even more productivity and creative freedom than ever. So let's take a look at the few key technologies that make this possible. So as I mentioned, NVIDIA fundamentally changed computer graphics with the introduction of RTX technology in 2018. And then now we've introduced the next generation, the second generation of RTX technology with NVIDIA Ampere GPU architecture. And what Ampere does is it provides second generation RT cores to deliver up to twice the throughput of previous generation hardware, giving you even more speed to interact and design with ray trace scenes and explore even bigger ideas. We've got third generation tensor cores to accelerate AI-based tasks. And for you guys, this is probably the most interesting thing would be with working with AI features in SOLIDWORKS Visualize, like AI denoising, and I'll talk about what that is soon. But there's other things like deep learning super sampling, or really just doing more traditional deep learning training and inferencing work that you might be getting into now. And up to basically one of the biggest improvements is 2 times the single precision performance in the latest generation streaming multiprocessor, or CUDA cores. It's basically the primary cores on the GPU. So what do these different types of GPU processing cores mean to you really as you use SOLIDWORKS? It means you can work on large assemblies with full fidelity graphics without interruption and get your photorealistic images and animations faster than ever before. I like this this animation here too. So first, there are the RT cores. Basically, what they do is they help accelerate the math that's needed to trace the virtual rays of light through a scene very efficiently, leaving the CUDA cores, our traditional simultaneous multiprocessors, to focus on shader calculations, or really generating the colors of your pixels. So they make ray tracing really, really fast, those RT cores. Then there are the tensor cores, which accelerate artificial intelligence tasks like AI denoising used in SOLIDWORKS Visualize. When you turn on AI denoising, Visualize completes about 10% of the brute force ray tracing calculations needed to fully ray trace the scene, and then artificial intelligence denoising jumps in and instantly finishes the job, providing you with incredibly close approximation to what the final fully converged image would look like. This allows you to iterate on your design based on your ray trace results. So you're getting that very near to the final ray traced result in 10% of the amount of time that it would normally take you. Keep on iterating on your design, and then when you're done, do a fully converged ray trace result at the end if you want, or use the AI version. It's fine either way. So SOLIDWORKS Visualize is one of the first product design focused visualization tools to harness the power of the GPU. It's also one of the first to add support for NVIDIA RTX, and it supports multiple GPUs. And SOLIDWORKS Visualize is really actually built on NVIDIA iRay technology. So we wrote the core SDK that they use to do the ray tracing. And iRay takes full advantage of our streaming multiprocessor NVIDIA CUDA cores and is tuned to get the best performance on NVIDIA RTX GPUs with their optimized drivers and RT cores and tensor cores. So SOLIDWORKS takes full advantage of NVIDIA RTX to speed up product design workflows. And how does it do that? So SOLIDWORKS itself benefits from the large memory and high performance of NVIDIA RTX GPUs to deliver a really fluid CAD experience, even with the largest models and assemblies. And this is a lot of what Alan was talking about earlier with NVIDIA working closely with SOLIDWORKS over the past several years to help them optimize their graphics pipeline, to push the majority of the visualization work over to the GPU. Prior to that, with older implementations of OpenGL, they were spending a lot of time, and this was the right way to do it back then. They were spending a lot of time on the CPU, creating the frames and then sending them to the GPU. Now, much more of that work is done in a modern OpenGL pipeline on the GPU, and that's what SOLIDWORKS has done. And what it does is it gives you smoother spin, pan, zoom operations at full model fidelity. No more need to reduce the level of detail in your largest assemblies when you're manipulating them. So when you spin, pan, zoom a large assembly and you want to focus in on a particular area, you don't have to wait for those small components to come back when you release the mouse button when you're spinning. They're just there all the time. You can zoom right in and get to your area of focus more quickly. NVIDIA RTX even provides the performance needed to dynamically review SOLIDWORKS models in VR with eDrawings Pro VR. That's another application provided by SOLIDWORKS that highly leverages the NVIDIA GPU and will give you great performance as you move up the stack in NVIDIA GPUs. SOLIDWORKS Visualize lets you take the review of your CAD models a step further, rendering incredibly quickly with photorealistic quality thanks to the ray tracing and AI denoising technology that we talked about. And really, as a designer engineer, being able to accurately visualize your components early on in the design process leads to more efficient design reviews down the road and fewer changes down the road when they become more expensive. And I think that, I guess that's it. To recap, whether you're looking into really RTX-powered laptops, desktops, virtual workstations are all great choices to take your work to the next level. With the NVIDIA Ampere architecture at the heart of these solutions, we're really offering you our most advanced GPUs for professionals yet. You can learn more about them at the NVIDIA. You can learn more about the NVIDIA RTX solutions on our website or by going to the DELL portal that we'll show you in a few minutes that we've done with TriMech. Alan?
Perfect. Thank you very much, Don. That was really cool. And there is one question that was asked by Jason when I shared my data opening the assembly. Was there any rebuilding happening? So that's actually a very good question, and you probably noticed there was nothing happening in phase number 4 of the assembly opening. There were no mate computation also, and the reason for that is I wanted to pick an assembly where I know exactly what happens internally, and I wanted to stress test the single core capability and also the multi-core capability plus the GPU engine. You probably noticed when I displayed the graphics data from performance evaluation, that actually comes from the rebuild report. And there was really nothing that took more than 1/10 of a second on the rebuild side, only the graphics computation. So if there is nothing that happens that takes more than 1/10 of a second, it's actually not reported by performance evaluation. Now, one thing that Don told us, and I hope, Don, you don't mind me disclosing this, as we were preparing for this meeting, is that it's worth redoing all these tests in Windows 11. So as I believe on the next webinar, we will have more interesting data. And I'm not going to go in details right now, but I'm really optimistic that we're going to see future gains where we combine the capabilities of today's hardware with today's software. And let me just steal the mouse and keyboard from Scott and Don. Thank you very much to both of you, and I think you're still going to have a few questions to answer. There is one more important thing. TriMech and DELL partnered. We actually work with our own clients to understand their needs, and then we talk to DELL and we recommended certain tweaks to the configuration of the workstations. Moreover, we put together a partnership that is going to be highly beneficial for our clients. You can see here the link to how to get there. Also, if you want to just simply take a picture of this presentation, you have the QR code. So I'm going to explore this portal live right now. So let me just simply click on that. The first thing I noticed before even going through all the other options, the prices that I see here are out of this world. So these are the previous generation of laptops. Actually, this is the one that I'm using right now. It's actually, oh, this got updated. So actually you can see, no, sorry, this some of them are older generation, some of them are newer one. But take a look at the discounts here. So 50%, 35%. It's pretty out of this world. Moreover, for our clients, we work with DELL to designate a dedicated account executive. So and maybe Luis or Scott, you can jump in and tell us a few more about these advantages. And there is one more thing that also I wanted to clarify. There is a magic button here, get coupon, so you can get extra savings in addition to what you're seeing right now on the screen. And feel free to click on all the other areas to learn more about this exciting offering. Anything else to add here, Scott or Luis?
Yeah, I'll jump in. So a couple of things. Yeah, that's really, I'm glad you mentioned that. So you see the incredible.
Oh, and by the way, you have the mouse. If you want to move anything on the screen.
Oh, okay. Thank you. Yeah, you can see there's some pretty credible discounts, and again, that get the coupon stacks on top of those other discounts as well. So if for customers that you know, are unsure what to buy, and all of these, by the way, are all recommended for SolidWorks. But if you're still unsure what to buy, you can reach out to Akshay here. His email's right here, and he can help you with any questions you might have related to configurations or discounts or how to actually purchase. And also, you know, Aline mentioned that, you know, there may be some customers here that are from Canada. So this program right now is only in effect for the US, but if you are calling from Canada or you know, attending from Canada or other regions, please just reach out to Akshay and he can get you connected with the right salesperson, and they can apply many of those discounts that you saw above to the system. So just reach out to him. I'm not promising every single discount will be available in different regions, but many of them are. So reach out to Akshay to get all the details on that. And then also just be aware, I know, you know, many of you, your companies are small companies, and DELL does offer some financial services here if you guys want to finance your purchases, you know, so it becomes OPEX versus CAPEX, depending on how you guys like to buy. You can take advantage of those, and there are, you know, really great payment terms available through the DELL Financial Services Group. So that's it, Aline. I think we do have some questions that people have come up with.
Thank you very much, Scott. Actually, Jason has a couple of really interesting ones. First of all, do I know if SolidWorks has new codes? And when I say new code, we're talking about SolidWorks 2022, which I tested, that takes advantage of the new class of GPU or CPU or GPU architecture. So on the GPU, absolutely right. I know that Jason knows, but I'm just going to mention for everybody else. There is, since SolidWorks 2019, there is a new code available in system options that you can turn on to take advantage of the GPU graphics pipeline enhancement, and that is scalable. Sorry, go ahead.
So you're right, Alan. In 2019, that was optional to switch over to the new graphics pipeline. In 2020, it's on by default. So I think it's 2020, 2021, and 2022. The new pipeline is used by default, and especially if you work in any kind of large-ish assemblies and have anywhere near a modern graphics card, you're going to have a better experience with the new graphics pipeline, because again, like I mentioned earlier, they no longer reduce level of detail. But this is kind of true throughout SolidWorks anyway, right? SolidWorks always conditionalizes their code to respond appropriately to the type of hardware that it discovers that it's running on, right? So it's always a good idea to use later versions of SolidWorks with later versions of hardware, and you'll get better experiences. We certainly work together with them in doing that sort of thing so that they can conditionalize it appropriately to give you guys the best user experience possible.
Right. And just going to add to this, if in SolidWorks 2019 or 2020 or even 2021, you try this new settings, this new technology really, and you found all kind of little imperfections or maybe major bugs, which made you uncheck the box and go back to the old pipeline, I strongly suggest, once you upgrade to SolidWorks 2022, especially if you are in the latest service pack 3.1, or you are trying SolidWorks 2023, to give this technology another try. Based on my experience, most of those pesky bugs that were inherent to a new technology got squashed by SolidWorks. And exactly what Don was saying, you're not going to see those kind of stop and go when you start spinning, and you don't have to degrade the graphics detail anymore, even in dynamic mode.
Yeah, that's
Yeah,
right.
guys, I'll add two other points to that. First of all, on the graphics side, in the latest generation of hardware that Dell just launched this year, I should say almost all of the graphics cards from the NVIDIA side, they're double the amount of RAM in the previous generation. So what does that do for you? That allows you to load even larger models, you know, and as we all say, your models never get simpler, right? Every year they get more and more complicated. So that's a huge benefit. And then one other thing I'll just touch on, and again, Aline alluded to this, is on the CPU side in the workstation, with the new hybrid core architecture that I spoke about, because of the hybrid core architecture with those performance and efficiency cores and the new Intel thread director, it has a much more efficient way of arbitrating the task to the CPU cores. And we're not seeing that in any of these benchmarks yet. And even, we're probably gonna have to design a specific benchmark just to really measure this, because it's really interesting. What happens is, typically when we run benchmarks, we try to isolate the system in a sense of, we make sure the only thing running on the system is the benchmark, right? So we can really truly measure that benchmark. But in the real world, that's never the case, right? You guys all know that as you're running SolidWorks, there's many other things running in the background. You know, there's Windows processes running, there's other applications that your IT department has put on your system, you know, probably for security and antivirus and all these kind of things that are actually running on a real world system that we're not typically measuring in benchmarks. But some analysis that we are starting to do right now, we're seeing tremendous benefits, because what happens is the Intel thread director starts putting those background processes on the efficiency cores, and then it allows the full performance of the performance cores to be utilized for SolidWorks. So we're expecting to even see increased benefits beyond that in the real world, and hopefully we'll be able to invent some benchmarks to show you how that actually works in a future webinar.
I'm glad that you mentioned that, Scott. And also going back to what you said about double the memory on the GPU, you pretty much gave me the explanation about why, when I start working with a large assembly and from there I open a large sub-assembly from it. When I return back to the top level assembly, I no longer have to wait for the graphics to be computed. Probably there is enough now memory for the previous image of the large assembly to still be stored in the video card, so it doesn't have to be recomputed again. And that is something that would resonate with many of you. You know how annoying is when you simply open a part from an assembly, you don't do anything to it, you just look at it and you go back to the assembly and you have to wait for 20 seconds or 30 seconds. That's
a great point, Alan. That's a great user experience improvement. I mean, all the time you're going to be going into a component or a sub-assembly of the assembly that you're focused on and wind up in that situation. That's a frequent workflow. That's a great point.
Yep. And there is a follow-up on that. Actually, it's an interesting one. I'm going to ask Scott that, and maybe even you might have experience with that.
I have a comment on that one. Yeah.
Yeah. What about mixing, moving away from Intel and maybe using just AMD products, AMD for the CPU, AMD or AMD and NVIDIA? Sorry. So CPU, AMD, but NVIDIA video cards. So what's your experience with that?
Yeah, I'll give you a little bit of feedback, and then I know Don has some. So, and I'm glad somebody asked that question, because I didn't really mention it in the slide where I showed that product overview. But Dell Precision Workstations just announced a launch of a new workstation that's coming out later this month. It's called the Precision 7865. This is an AMD-based Threadripper CPU workstation. And many of you have probably heard stuff about Threadripper, and it's very good performance when it comes to multi-threaded operations. So when we were talking about like SolidWorks simulation, which is the best example of CPU multi-threading, that system is going to perform very, very well. Okay. But, you know, and when you, to get more to your question about, you know, using an AMD CPU with an AMD GPU, et cetera, or an NVIDIA GPU, what we're finding is, you know, the NVIDIA GPUs generally outperform any of their competitors. So we would highly recommend NVIDIA GPUs when you're looking for performance. That's really the ideal situation. And because of the architecture of the system, it doesn't matter whether you're using an NVIDIA GPU with an Intel CPU or an AMD CPU, it's still going to perform well. So I'll leave it there, and I'm sure Don has a little bit more insights.
What do I say to that, Scott? No, I think you're exactly right, and that's NVIDIA GPUs work absolutely fantastically well with AMD CPUs. You're welcome to use them if you want. I don't recommend you use an AMD GPU, but hey, that's me. You heard it from the Dell guy.
Yeah, and again, you know, it's perfectly viable using AMD products. We sell them as well, but our benchmarks consistently show NVIDIA outperforming the AMD GPUs. Yep.
Thank you very much for sharing that information behind the scene. It looks like we're gonna have a lot of material for a follow-up webinar in a few months with the new system that Scott was mentioning, and also we're gonna do quite a bit of new testing on SolidWorks 2023. Those of you who are involved in the beta testing of 2023, which by the way should be everybody because it's for free and you don't have to do anything, just go to the SolidWorks community and just join the beta testing forum. You might already see some of the crazy questions that we at TriMech are asking, because we are floored about what we're seeing there in regards to performance of large assemblies in 2023. So I guess very soon, once the NDA is lifted, I'm going to invite again Don and Scott for a follow-up webinar where we're going to focus again on the hardware and in conjunction with the new software, and again marvel about the improvement in performance that we expect that you, our clients, are going to see very soon. And with that being said, I don't see any other question. I just want to thank you everyone, also to thank you our experts today, Scott and Don, for participating in this. And don't hesitate to write to us if you have any other follow-up questions. All three of us would be more than happy to answer your questions. Paige also informed me that this has been recorded, so feel free to share the recording with your colleagues, with your friends, and stay tuned for the next webinar that's going to be focused also on performance. Thank you very much today. Bye.
Sounds good. Thanks for having us, Alan.
Thanks, guys. Bye, everybody.